All right, so we're going to start with the calculator part of this review. Remember to use this review for the quiz, but also the old quiz review that you got on Monday. Make sure you're looking over that too for some true or false practice. All right, find the balance of an account in which $7,500, that's P, was invested at an annual interest rate of 2.5%. Change that to a decimal. Where interest is compounded, we're going to round to the nearest cent, even though normally we do 3 places. Okay, semi-annually is n equals 2, quarterly 4, daily 365, continuously is PE to the RT. So you need to have your interest formula, compound interest formula memorized. It's A equals P times 1 plus R is a decimal over N raised to the NT power. Oops, I just realized I didn't put in a year. So let's say T equals, we'll do 15 years. All right, so to the 2 times 15 power. And then it should just be a matter of typing this into your calculator. So 7,500 times 1 plus 0.025 over 2 raised to the, I like to do time and then n, just so I can make quick adjustments that way. All right, so when you write your answer, make sure that you're labeling with dollars, and the instructions say round to the nearest cent, which means 2 decimal places. So for quarterly, we're just changing out n equals 2 to n equals 4. So I'm going to show my work here for the key. So this is now to the 4 times 15. So I like to do second enter and just type over my 2 and make it a 4, and make sure I make the same adjustment right there. So this answer should be slightly higher, which it is, 10,899.71. And then we switch to daily. So for daily, I'm going to do second enter again. Now daily is a little more annoying because you have to insert places. So I'm hovering over the 4. I would like to insert 2 more places here. So I'm going second delete, 3, 6. And then you have to kind of arrow off so that it doesn't keep inserting places in. So I changed that n to a 365. And then the reason I put this n on the end is so that I can just type without inserting. So this is 10,912.30. 29 is going to round up to 30. And continuously is, there's no n here, so this is 7,500 times e to the 0.025 t, which is 15. So 7,500 e to the 0.025 times 15. So we get 10,912.44. All right. For the next problem, let me just box these in here. For the next problem, it says, now we have $20,000. $20,000, there's P, is invested at an annual interest rate of 3.25, so 0.0325, compounded continuously, PERT. How long will it take the initial investment to grow to $30,000? We're going to round to the nearest thousandth because how long is talking about how many years. Include units in your answer. So first we would need to show that we are setting our amount, our balance, equal to 30,000. That's equal to the initial 20,000 compounded continuously. So PE to the R T. And we're going to use our graphing calculator for this because 1, it's fast, and 2, we haven't talked about solving these exponential equations yet. So, all right, my calculator is a little glitchy. It won't let me go to Y1, so I'm just going to type in 30,000 into one of the equations here. Type in the right side of the equation, 20,000 e to the 0.0325x. Now, what about the window? We don't have a set domain, but we know that we want the window to go from 0 to, I kind of just have to guess something here. How many years is that going to take? Certainly not 250, I would think. I'm going to start with like 20 years and just see if that fits. 0 to 20 years. Will this happen in 20 years? So then I'm going to zoom fit. All right, so that was a good guess. If I didn't see the point of intersection, I would just make another adjustment and then probably zoom fit again. So this point of intersection represents when my exponential function, my balance in the bank account hits 30,000. So find the intersection point. Round to three places, so 12.476. T is approximately equal to 12.476. Label that as years. Right. Next question is not about compound interest. So here we're given a function. The 1986 explosion at Chernobyl nuclear power plant in the former Soviet Union sent about 1,000 kilograms of radioactive cesium-137 into the atmosphere. Not great. The function 1,000 times 0.5 to the x over 30 models the amount of cesium-137 remaining in Chernobyl x years after 1986. Find the amount of cesium-137 in the atmosphere this year, including units. So this year is 2023. We need to know how many years after 1986 is 2023. So you can just subtract those. Probably could do that without a calculator, but we're talking about T being 30, what did it just say? 37. Okay, so we're trying to find F of 37, which would be 1,000 times 0.5 to the 37 divided by 30 power. And I'm going to pop that into my calculator. Oops. All right, so this year, there are still approximately 425.334. 425.334. I need to label this. The function f of x is the amount of cesium, and cesium started in kilograms, so this is going to be kilograms left in 2023. An area with at least 100 kilograms of cesium-137 is considered unsafe for human habitation. How long after the initial explosion will Chernobyl remain uninhabitable for humans? So once it gets under 100, people could start going back. So we're looking to solve, let's just find out how long will it take to equal 100, and it would be any time after that. So for our AP test, we would need to show some setup like this. And then if we're allowed to use a calculator, there's not really anything else to show. So I would, again, solve on my calculator. So 1,000 times 0.5 to the x over 30. You kind of have to guess at the window again. Now, when we put in 37, we were only at 425. So I could bump this out to 100 or maybe even 200 years would be good. And then I would zoom fit. All right, so 200 was plenty. 100 might have made it. Let's see where this point of intersection is. Yeah, so 100 would have just fit. I would have had to bump it out a little bit. So 99.658. T is approximately equal to 99.658. This is years after 1986, right? So basically, let's round that to 100. Basically, in 2086, we could say, all right, you can start going back to that area. All right, I put some targets on here. This is something that we actually talked about on Tuesday. So just kind of targets for you, making sure that like we just practiced this skill. Do you feel confident that you know both of the compound interest formulas? I want to make sure you have those memorized. Can you use them to find a balance after a given time? Okay, so hopefully that answer is yes. That's basically, could you do more problems like number 1? And then the second question is, I can solve an exponential equation by finding an intersection point on my calculator. That's basically, can you do questions 2 and 3? Right? So if you don't feel confident about those, make sure that you come into office hours or flex and ask me for some more practice on those. Okay. Non-calculator part for graphing. So you need to know the rules for your exponential and your log functions. So this is starting out an exponential function. The original nice points are 0, 1, and 1, 2. And it has a horizontal asymptote y equals 0. Remember our normal exponential function, something like that. This graph has gone left 3, down 4. So all of these points need to be shifted left 3, down 4, and the down 4 affects the horizontal asymptote. So down 4 is what I like to sketch in first. Horizontal asymptote. The point that was at 0, 1 goes down 1, 2, 3, 4. The point that was at 1, 2 goes down 4 units. And I sketch in my graph. So all that's required is that you find the two nice points and the horizontal asymptote. If you're asked about domain and range, the easiest thing to do is take a look at your graph. So the domain is all real numbers for any exponential function. The range has to do with the asymptote, anything from -4 to infinity, but not actually including -4. This doesn't say horizontal or vertical asymptote, it just says asymptote, so you need to recognize this is a horizontal line. It's an equation that I want, so I want y equals 0, not just the number. I want y equals -4, not just the number -4. And for the y-intercept, I can see this on my graph. I can also say f of 0, if you want to do the math behind it, is 2 to the third minus 4. I would really only do the math if I couldn't see the y-intercept on my graph for some reason. So this one you can just get right off of your graph. It is 0. Oh, wait, what did I just do? 2 to the third minus 4. It's 0, 4. Wait, why is that happening? Oops, I forgot to go left 3 and down 4. It's like, why isn't the math matching up? I guess it's good that I did it, right? Let's try this again. The point that was at 0, 1 goes left 3 and down 4. There we go. And the point that was at 1, 2 goes left 1, 2, 3 and down 4. There we go. So here's a great example of like, hey, I didn't plot enough points to get a nice answer. Now I know when I plug in 0, I get 8 minus 4. So the y-intercept is at 0, 4. Good to know. I could plot that on there if I wanted to help my curvature, but I don't necessarily need to. All right, on to the next one. Our original nice points are 0, 1, and 1, 1/3. You could also go the other way. You could say like -1, 3 is a nice point to begin with. What has happened to this graph? We have an x-axis reflection, which means that all of the y values get multiplied by -1. So 0, -1, 1, -1/3. And then we're going to be going up 2. The line that was at y equals 0 is now going to be at y equals 2. So up 2. And then we have 0, -1, but then go up 2. And 1, -1/3, go up 1, 2. It's kind of a hard one to sketch in. Again, if you wanted another nice point, -1, 1/3 to the -1 is 3. So then this would become -1, -3. And then you go up 2. If this helps you with the curvature at all, it's kind of hard to see on that one. All right, and then domain. all reals, range negative infinity up to 2, but not including it. We have a horizontal asymptote at y equals 2. And the y-intercept I can see on my graph, but I can also verify algebraically if I need to. Negative 1/3 to the 0 power times negative 1 plus 2 is equal to negative 1 plus 2, which equals 1. Switching gears to log graphs. So the nice points on the log base 4 graph are 1, 0, and 4, 1. The 3 that's out in front means every y, it's a vertical dilation, every y gets multiplied by 3. And then the minus 2 is right 2 units. So we have a vertical asymptote at x equals 0. When we go right 2 units, that's going to move this to x equals 2. The point that was at 1, 0 goes right 1, 2. The point that was at 4, 3 goes right 1, 2. So this graph has been stretched vertically. Try to make that sketch a little bit better. There we go. Domain for this one is 2 to infinity. Range is all real numbers. The vertical asymptote this time is x equals 2. And the x-intercept, I can see it on my graph. It's 3, 0. But you can also say 0 equals 3 log base 4 of x minus 2. You have to get the 3 out of there. Get the log by itself before you start switching things around. So 0 equals the log base 4 of x minus 2. 4 to the 0 equals x minus 2. This is me writing the equation in exponential form. This is 1. 1 equals x minus 2. X equals 3. So that checks out. If you can see it off of your graph, you don't have to show me the algebra. All right, number 7 needs a little bit of fixing. We've talked about this in chapter 1. Factor the negative out anytime you have a y-axis reflection and a horizontal shift so that you shift in the proper order here. So the original nice points are 1, 0, and base 5, so 5, 1, and x equals 0. The negative on the inside means every x gets multiplied by negative 1. So this is going to be negative 1, 0, negative 5, 1, x equals 0 is still x equals 0. And then you're going to go right 1, up 3. Right 1 is going to change the vertical asymptote to x equals 1. Okay, so right 1. And then the point that is at negative 1, 0 would go right 1, up 1, 2, 3. The point that's at negative 5, 1 would be right 1, up 1, 2, 3. So I've got these 2 points here. This was a y-axis reflection, so the graph should be curving down on the right and sort of gradually increasing on the left. The domain is negative infinity to 1. The range is all real numbers. Vertical asymptote is x equals 1. X-intercept is not a nice point, so we are going to have to solve for this one algebraically. So first, set your log function equal to 0. Next, get the log by itself. Next, rewrite in exponential form. So change this log equation to exponential form. That's 5 to the negative third equals the result, which is negative x plus 1. 5 to the negative third is 1 over 125. We're going to subtract 1 from that. That's negative 124 over 125 equals negative x. So x equals 124 over 125 positive, which seems fine, right? Because I got something that's less than 1. So, okay, so we'll call it that. That's our x-intercept. All right. So for graphing, I have this little checklist on the back page. I can graph 2 nice points in an asymptote for both exponential and logarithmic functions. I can identify transformations, so you can correctly say what's left, right, up, down, and reflections and stuff, and graph those transformations of both types of graphs. And I can find the x-intercept for a log function by setting the equation equal to 0 and rewriting an exponential form. So you want to make sure you can do all three of those things. And again, if you're saying like, well, I didn't quite get the hang of that x-intercept thing, please come in and ask for more help on that. Or you can also probably search for help on that and find some good explanations as well. All right, the last three check marks are I can do level 1, level 2, level 3 problems. So here's what I'm talking about with those. A level 1 evaluation problem is just a one-step evaluation. So remember, evaluate and simplify. Evaluate means find the exponent. 2 to what power is 32? 2 to the 5th power is 32. Logarithms are exponents, so we're just reporting the 5. 3 to what power is 81? 3 to the 4th power is 81. E to what power is e to the 5th? You can see the power right here. What power is the result being raised to? 5. This one's base 10. You can't see it. But 10 to what power is 10,000? Just count the zeros. 1, 2, 3, 4. So 10 to the 4th is 10,000. That means 4 is my answer. If it's natural log, you're just saying what is the power on this e. If you want to rewrite it, you can. Square root of e is e to the 1/2. So the answer is 1/2. 4 to what power is 1 over 64? So we're going from a whole number to a fraction. Answer's got to be negative. 64 is 4 to the 3rd, so my answer is negative 3. 64 to what power is 8? If you're going from a large number to a smaller number, but neither are fractions, then we've got to have some sort of a root. So the square root of 64 is 8, which makes this 1/2. 1 over 4th root of e cubed. Remember, that's the same as saying e to the negative 3/4 inside of your natural log. So the answer is negative 3/4. So go from e to 1 over e, your answer is negative. And if e has a root, that's a rational exponent. So those are all level 1. You should be able to answer the question of the base number to what power is this result. Level 2 questions might take 2 steps. Evaluate first and then simplify. So evaluate each of these terms first and then combine the terms. So natural log of e is 1. E to what power is e? Natural log of 1 is 0. E to what power is 1? 0. 2 to what power is 1/8? So we've got minus negative 3. 2 to the negative 3rd is 1/8. So 1 plus 0 plus 3 is 4. So 2-step problems, meaning maybe you write out more than 2 steps, I don't know, but evaluate each term and simplify. Again, evaluate each log and simplify. You are not allowed to cancel logs out. That's not a thing, so those don't cancel. But you can say 5 to what power is 125? 3. 3 to what power is 3 to the 6th? Well, you can see the 6 on there, so don't go figuring out what 3 to the 6th is. 3 over 6 is 1/2. So again, simplify each term. 2 log base 2 cancels out. That's 15. E to the natural log cancels out, minus 4. E to what power is 1 over e to the 4th? That's minus 4 as well, plus negative 4. 15 minus 8 is 7. That's our final answer. All right, I'm trying to trick you a little bit on 19. I want to know if you're going to do the square root part incorrectly, so be careful on this one. Start on each term here first. Natural log of e to the 4th is 4. Natural log of e to the 16th is 16. Natural log of e to the 25th is 25. What you're meant to do is add these together. 4 plus 16 is 20, plus 25 is 45. So 3 radical 5. What you're not allowed to do, this is illegal math, you're not allowed to say 2 plus 4 plus 5. You can't square root and get a different answer and say it's the same thing. So you're not allowed to square root each term. Order of operations says there are sort of, think of these as invisible parentheses. The square root is parentheses. You've got to do the math underneath first, then you can square root. Parentheses comes before exponents, and then you can simplify. I'm just going to label this as illegal. Okay, next one, log base a of a to the third. If the base number matches the results, then no work to do, it's just 3. This is 4 times log base b of square root of b, 4 times 1/2. 3 plus 2 is 5. For this one, e to the natural log of 2 is 2. 5 to the log base 5 of 6 is 6. 2 to the log base 2 of 16 is 16. 8 over 16, I want you to reduce as 1/2. Level 3 questions, this is about as far as we take them. You might have to use log properties first, and then you can evaluate and simplify. So you're not allowed to make this 12 minus 3. First, you have to condense into e to the natural log of just one thing, and then you can use your property. So I wouldn't get the same thing if I said 12 minus 3. I wouldn't get 4, which is what it should be. We've had this a few times now. Anytime we're multiplying logs together and you can't simplify them inside, use change of base. This is log of 4 over log of 3. This is log of 27 over log of 4. Each time we've done this problem, a pair of logs divides out to 1. Log of 27 over log of 3. And then you're not done yet because you've got a sort of reverse change of base. Write it back in this form, log base 3 of 27, and it's something you evaluate. Okay, for 24, again, I can't simplify the individual terms like I could in the previous section, so I have to rely on condensing first. This is the log base 3 of 6 over 2, which is the log base 3 of 3, and that can be evaluated. 3 to what power is 3? That answer is 1. Okay, this is kind of same thing as 22. I have to condense this first. This is e to the natural log of 18, 6 times 3, minus log base 3. Now, I do not want to do a bunch of tough math here, but I can say this is 27 to the 1/2, and maybe I raise that to the 6th power, because that should simplify things a little bit. Log base 3 of, this becomes 27 to the 3rd, and I still don't want you to figure out 27 to the 3rd. Nothing we do should have really high numbers on our quiz. So if you're calculating these really large exponents, there's probably an easier way. 27 is 3 to the 3rd. So instead of 27, we're saying 3 to the 3rd raised to the 3rd power. Instead of 27 to the 3rd, we're really looking at log base 3 of 3 to the 9th. And again, don't bother figuring out 3 to the 9th. Just say that's 18 minus 9. So final answer is 9. Okay, and the last thing that, again, we've had on a few homework assignments and practices in class, rewrite each expression in terms of a, b, and c, given that these 3 logs are what we're using for a, b, and c. So the steps on this are expand, rewrite numbers in terms of 2, 3, and 5 if they're not already. You'll probably have to expand again. And the 4th step should be, once everything's all expanded, sub in letters or simplify terms. So take a look at this. We've got log base a of 10 plus log base a of a cubed. So expand, done. Rewrite the numbers. Instead of 10, because that's not a 2, a 3, or a 5, 10 is 2 times 5. Log base a of a to the 3rd is 3, so I can simplify that term. Step 3 is expand again. When you rewrote 2 times 5, you can expand that out into log base a of 2 plus log base a of 5 plus 3. The log base a of 2 is capital A. The log base a of 5 is capital C. and then I just have a plus 3 on the end. Same thing for the next one. Expand log base a of 5 plus log base a of the square root of a minus the log base a of 6. Log base a of 5 is c. Log base a of square root of a is 1/2. 6 needs to be rewritten, minus log base a of 2 times 3. 3 times 2, order doesn't matter. Be careful when you expand this. You're subtracting this sum, so it's going to be minus log base a of 2 plus log base a of 3. Either put the addition in parentheses or distribute the negative through right away. So we have c plus 1/2 minus capital A minus capital B. And you can change the order up of that if you want to. I'm just going to leave it as it is. Okay, last problem. I'm going to pull this 1/2 out in front. 1/2 log base a of 90 plus log base a of a. 1/2, let's see, 90 is 9 times 10. 9 is 3 squared times 10 to get 90. So 3 squared times 10 plus log base a of a is 1. Expand. 1/2 times log base a of 3 squared plus log base a of 10. Oh, 10, sorry. 10 should be, let's make that 2 times 5. So log base a of 2 plus log base a of 5 plus 1. This 3 squared, the 2 can come out front. So we're going to have 1/2 times 2 times log base a of 3. And then I'm just going to sub in letters for these other ones. And final thing, 1/2 times 2 is 1. So we're going to get, if we distribute this all the way through, we're going to get 1/2 times 2 log base a of 3. So we're just going to get b. Then it should be plus 1/2 a plus 1/2 c plus 1/2. Or if you want to leave the 1/2 on the outside of parentheses, that would be okay. 1/2 times 2b plus a plus c plus 1. Either way. All right, so finishing out the checklist, I can evaluate level 1 problems. Those are sort of like our first type that we worked on. I can evaluate and simplify level 2 problems. I can evaluate and simplify, meaning like condense. Usually this means condense. And simplify level 3 problems. So if you were able to do all of these problems and understand them, that's great. And if you want more practice, I would say it would be a good idea to go back to some of our first couple logarithm assignments and just kind of make sure, now that you've done these for a while, go back and make sure you can really do these. Because I know that sometimes we kind of do our homework a little bit mindlessly, and you might need to go back and just make sure you understand what was going on for this assignment and some of our previous other ones. All right. Okay, that's it for today. Come on into office hours or flex if you have questions.